Hello, my name is Nakanishi from Japan, and I'm a master course student of Shibara Institute of Technology. Today, I'd like to talk to you about stereo measurement without markers for moving solid surfaces. At the beginning, I'd like to show you the contents of my presentation. The first content is introduction, including overview and objective of my presentation, and next, methodology. I'd like to show you methodology, experiment, and results. And finally, I'd like to conclude my presentation with some discussions. 3D measurement of moving objects is required in disaster monitoring and construction fields. Let me give you some examples. For example, passengers and traffic flows should be required for traffic design, and automated construction should be required for soil and sand and ready mixed concrete surfaces. So in this study, we focused on landslide. Here is objective. About landslide measurement, 2D approach exists, but there are really few 3D videos, and most of existing 3D analysis techniques are manual. So in this study, the new technique for automated and 3D measurement is proposed. Methodology. Here's methodology. As the starting approach, two functions combined. The first is stereo measurement, which is required for 3D coordinate value equation with stereo camera. The next is motion tracking, which is required for feature point tracking. Here is stereo model for including epipolar geometry. In this, for triangulation, feature point in images must be acquired. Then 3D coordinate values are acquired. Here's template. How to template matching. And this time, the searching range is not limited. So in stereo matching, the corresponding points exist on this on epipolar line. So searching range will be narrower. Here is general template matching equations. The first is SAD, sum of absolute difference. Next, the second is SSD, sum of squared difference. The third is NCC, normalized cross correlation. In our preliminary experiment, NCC has the highest succession rate. In this study, we focused on accuracy, so NCC is applied. The next feature point in feature point tracking, searching corresponding point, search corresponding point with restriction, and searching range is restricted to downward. Here is general feature point tracking equations. The first is global gradient methodology. The second is local gradient methodology. The last is block matching methodology. In this study, block matching methodology is applied. Here's how to process feature point tracking. This slide showed how to cross matching composed of stereo matching and temporal matching. First, each stereo matching between right and left images in each scene, and temporal matching between each scene is done. And the next step is template matching between the result of the previous step, stereo matching and temporal matching. Here's experiment. We use Nikon D300 as stereo camera. The focal length is 70 millimeters, and baseline length is 15 centimeters. And shutters are released automatically, and stereo image is synchronized in plus minus 1/30th second accuracy. We use object. We measure object. Three kinds of object. The first is Toyota standard sun with particular light color particular and grain diameter. Its grain diameter is less than 1 millimeter. And the second is cracked rock with particular dark color particular and grain diameter, and its grain diameter is more than 2 millimeters. And the last is mixed sand, which has dark and light color particles. Here's parameters of our experiments. First we get continuous 58 stereo images, and here is four kinds of parameters. First, feature points and template size are applied in both of stereo and temporal matching, and searching range. And the next is searching range for stereo matching. This is distance from camera to objects plus minus 20 centimeters. The last is searching range for temporal matching. This is 7 by 11 pixels. In our experiment, we simulated landslide, as you can see in this figure. Here's the result. Here's feature tracking result. In right picture, black cross is the previous feature point, and the blue circle is tracked feature point. And we can get optical flow, as you can see. Here is feature tracking result in 2D. And if we arranged feature point in much more density, we can get point cloud data, as you can see in this figure. Here is tracking result in 3D, but however, sometimes matching error called spike noise occurred. This is conclusion. Our goal is 3D measurement of continuous behavior of sun and soil surfaces without markers, and the methodology is stereo measurement. Sorry. Methodology is cross-matching, composed of stereo measurement and motion, stereo measurement with stereo matching, and motion tracking with optical flow estimation. And the experiment is simulated, and we conducted experiment with simulated landslide and its sample data. In the future, if self-verification matching system and automation of revision is realized, achieved, high accuracy and high speed processing will be realized. Here, this slide shows our future works. The first is accuracy verification without markers, and the second is higher processing, which will be achieved with parallel processing and weighting accuracy. Thank you for your kind attention.
Questions or comments?
This landslide is not a very simple phenomena as you have depicted here through experiments. It's not only the combination of sand and soil, the water is also involved, and you get boulders and rocks also are involved in the process of landsliding. So yes, it's a good attempt, and you are working towards automation of landslide prediction is fine, but then landslide is not, simulation of landslide in the laboratory is not simply sand and soil. It involves water, it involves vegetation, it involves so many other natural phenomena. Please incorporate that into your study, it will be a wonderful study.
That's a good comment.
Thank you for your comments.
This is a very interesting topic because it's a huge challenge. Normally, using stereo images, you need correspondence. But in this case, everything rolled together because of the sand, because of their size and the kinetic energy that must be released. So the points are no longer corresponding each other. So the previous position and the later other position that happens a few seconds later is not the same, perhaps not the same. So the accuracy check is going to be very hard, and I can only say that you may find your chances in doing that. And in terms of your future efforts, you're going to using weight, different weight, the third item of your future intentions. I'd like to know what kind of weight are you referring to in your future development? See, the last page, perhaps you can show the last page. Yeah, weighting. What do you mean by weighting here?
Thank you for your question.
In the same scenario, using the same instrument and the sand slide, what is weighting?
Weighting in this study, we composed two kinds of matching. Cross matching is composed of stereo matching and temporal matching. If either stereo or temporal matching occurs caused error.
Yeah. Do we have a Japanese friend in the audience who can explain to her? So it's, yeah. Okay. Thank you.
Thank you very much for your attention. The first question and the second question we have. So first question, actually we have improved, actually we have many problems like vegetation moving or smoke caused by sun particles. So this is a first challenge, our challenge. So this is the first step actually. And the second question is parameter weighting. So actually we have many parameters for stereo matching and motion tracking. So actually we have improved stereo matching and motion tracking using stereo corresponding epipolar restriction and restriction using landslide behavior. We don't have a slide, so unfortunately. So, but we can discuss after this discussion. Thank you.
I don't like to wait for after the session. I'd like to know the truth now. In my point of view, you don't need stereos. You use one picture. That's enough. You plant a small tree. You follow the tree. You get the speed of all the sense. Your solution. You don't use stereo to track the small sense.
You mentioned that resolution. Small sense means resolution.
The soil particles. The sand is so smooth, it's hard to track. Then Dr. Wu suggested that you can put some big object like a rock or a tree that you can track that. But yeah, you can consider that. Any other question? All right, then this concludes this morning's session. It's a well-attended session and fruitful. Thank you all for your attention. Thanks.
我先拿过去。